This is question number 953 in Leetcode, and it says the title of it is Verifying an Alien Dictionary. As I do this, I'm going to be yelling at Comcast support in the chat because they suck, but verifying an alien dictionary. What does that mean? Well, given a list of words where the ordering does matter, so for example like hello and Leetcode, return of this is in the correct ordering. And you might say that's easy, okay. But the trick with this question is they're going to give you an alphabet. So they'll give you an order, which is just going to be another string. Something along the lines of, let's see, for now I'll just say H, L, and then A, B, C, and then so on. The rest doesn't really matter for this example. But the trick is to use this ordering to essentially return whether this is in order or not. A counterexample would be if words was, so assume it's so assume the words are word, world, and row. And the ordering was world and then something else, doesn't matter. Well, because in this dictionary, how would we go through? We would say that L does become before D, this character and this character, the fourth character. So this is actually not in order. So we would return false. This question doesn't specify it, but in the order of a tie, so say you had two words, app and app, this would be considered a correct ordering. And then also, if we had app and apple, this would also be considered a correct ordering if these were the only two words, because shorter words are considered to come before longer words if they're the same for the length of the shorter word. So that's the question. Return true or false if it's in the correct ordering. How would we solve this? Well, very similar to how your brain would solve, really solve it by hand. So if you had a bunch of words, you'd really need to compare every single word, and then you just need to compare that somehow. For this app and apple example, how do you know, and just imagine like the English ordering of characters, how do you know this is later? Well, you go through and you compare the first character and it's the same, and the second, and the third, and then you're done with this, so you know that this one, it comes second. One sec. And so how would we actually tell whether something's in order or not? Well, really the key of this problem comes down to how are we going to store the ordering. So you could store it in a map. So I say for the example, we'll just be using the English dictionary, just A through Z in that ordering. Why not store A to map to 1, B to 0, and so on, and Z to 26. So that way, whenever we're looking at two characters, we can look at their relative value and compare them. So let's just start coding this up. So so we need that map. So we need to map characters to their order in the alphabet. And we'll just map the character to an integer. And then I will actually put that out here. Okay. So right off the bat, we need to build this dictionary. So let's put build dictionary, and then we'll just go through every word or every character in the order and put that in the map. So int I equals 0. So for every character, map.put, and we'll just put in I, or we'll put in C and I, and then we'll increase I right there. Okay, so we have our dictionary built, so we can compare characters pretty easily. And so now all we really need to do is just compare in between every single word. So let's compare the first two, and then so on. So starting at the first, or I guess really the second word, I is less than words dot length I plus. And then we'll just compare. We'll imagine we have a function just called isOrdered. Returns a Boolean, and it takes in just two strings. And so we'll have a function, so if something is not ordered correctly, so the first word and the second word, then if anything ordering is wrong, then we'll return false, and at the end we'll just return true if we have a correct ordering. So now this is the meat of the function, or meat of the heart. This is the most important part. So basically, given two strings according to the ordering we'd already dealt with, compare them. So we need to compare. So for this example, we were looking at with app and apple. We need to compare up to the minimum amount of characters. So let's do that. So I equals 0, I is less than whatever is smaller, first dot length or second dot length. And then, hoping my parentheses are balanced. I think we're good. What are we doing through this? We are comparing every character according to the ordering. So we're just going to say if whatever character at first, if that is less than the second one, that's good, right? Second char at I. We know we can exit. Why is that? So if we just had, assuming an English dictionary, if we just had a word named A and a word named B, B would come after A because B would map to like a 2 and A would map to a 1, and then it would find that. So we would just exit quickly. And the reverse is true too. So else if, and it's going to be the exact same logic, but with the sign flipped. So in the other case where there's a false ordering, so like it was just BA, we would return false. And in the other case where there's a tiebreaker, then we'll just try and compare the next character. But as you may see and your compiler will complain about, it's possible to get to this spot right here without having returned a value. So if we get here, we've gone to, we've compared the first parts of the word, and we need to essentially just return whether the first word is shorter than the second, because that would be the correct order. So for the app and apple example, we would want to return if this word is shorter than this word for a correct ordering. So I don't even know if I have internet right now. I guess in the meantime, so this is, let's see, we're doing, the runtime of this would be, we really have to go through every single letter in the words. So I would say it would be O of n, because it grows with the size of the words, where n is the number of words in this thing. In terms of space, this is a constant space here. We're not really storing anything, so I'd say it's O of 1 space. If you wanted to be more specific, you could say like O of k, where k is the number of words in the alphabet. Well, this isn't working. I will, you know what, I will refresh this and see what we can do. Run code. I. Looks like we already used I here, so I'll just move that. And it looks like it passes all test cases. So yeah, that's the alien dictionary question.